At the end of this video, I want you to be able to explain the roles of Mendeleev and Moseley in the development of the periodic table. The history of the periodic table, Mendeleev and chemical periodicity. Imagine the confusion among chemists during the middle of the 19th century. By 1860, more than 60 elements had been discovered. Chemists had learned the properties of these elements as well as those of many compounds that they formed. It's a difficult task. And to make matters worse, there was no method for accurately determining an element's atomic mass or the number of atoms in an element in a particular chemical compound. Different chemists used different atomic masses for the same elements, resulting in different compositions being proposed for the same compounds. This made it nearly impossible for one chemist to understand the results of another. In September 1860, a group of chemists assembled for the First International Congress of Chemists in Karlsruhe, Germany, to settle the issue of atomic mass, as well as some other matters that were making communication difficult. At the Congress, Italian chemist Stanislao Cannizzaro presented a convincing method for accurately measuring the relative mass of an atom. Cannizzaro's method enabled chemists to agree on standard values for atomic mass and initiated a search for relationships between atomic masses and other properties of elements. When the Russian chemist Dmitry Mendeleev heard about the new atomic masses discussed at Karlsruhe, he decided to include the new values in a chemistry textbook that he was writing. In the book, Mendeleev hoped to organize the elements according to their properties. He went about this much as you might organize information for a research paper. He placed the name of each known element on a card, together with the atomic mass of the element and a list of its observed physical and chemical properties. He arranged the cards according to the various properties and looked for trends or patterns. Mendeleev noticed that when the elements were arranged in order of increasing atomic mass, certain similarities in their chemical properties appeared at regular intervals. Such repeating patterns are referred to as periodic. The second hand of a watch, for example, passes over any given mark at periodic 60-second intervals. The circular waves created by a drop of water hitting a water surface are also periodic. Mendeleev created a table in which elements with similar properties were grouped together, a periodic table of elements. His first periodic table, as shown here and in figure 5-2, was published in 1869. Note that Mendeleev placed iodine, I, which has an atomic mass of 127, after tellurium, which has an atomic mass of 128. Although this contradicted the pattern, again, of increasing atomic mass, the pattern of listing the elements in order of increasing atomic mass, it allowed Mendeleev to place tellurium in a group of elements with which it shares similar properties. Reading horizontally across Mendeleev's table, this group includes oxygen, sulfur, and selenium. Iodine could also then be placed in a group it resembles chemically, which includes fluorine, chlorine, and bromine. Mendeleev's procedure left several empty spaces in his periodic table. Again, this is featured on figure 5-2 on page 124. And then in 1871, the Russian chemist boldly predicted the existence of properties of elements that would fill 3 of these spaces. By 1886, all 3 elements had been discovered. Today, these elements are known as scandium, Sc, gallium, Ga, and germanium, Ge. These properties are strikingly similar to those predicted by Mendeleev. The success of Mendeleev's predictions persuaded most chemists to accept his periodic table and earned him credit as the discoverer of the periodic law. 2 questions remained, however. Why could most of the elements be arranged in an order of increasing mass, but a few could not? 2. What was the reason for chemical periodicity? Moseley and the periodic law. The first question was not answered until more than 40 years after Mendeleev's first periodic table was published. In 1911, the English scientist Henry Moseley, who was working with Ernst Rutherford, examined the spectra of 38 different metals. When analyzing his data, Moseley discovered a previously unrecognized pattern. The elements in the periodic table were arranged in increasing order according to nuclear charge, or number of protons in the nucleus. Moseley's work led to both the modern definition of atomic number and the recognition that atomic number, not atomic mass, is the basis for the organization of the periodic table. Moseley's discovery was consistent with Mendeleev's ordering of the periodic table by properties rather than strictly atomic mass. For example, according to Moseley, tellurium, which has an atomic number of 52, belongs before iodine, which has an atomic number of 53. Today, Mendeleev's principle of chemical periodicity is correctly stated in what is now known as the periodic law, which states that the physical and chemical properties of the elements are periodic functions of their atomic numbers. In other words, when the elements are arranged in order of increasing atomic number, elements with similar properties appear at regular intervals. Hopefully now you can explain the roles of Mendeleev and Moseley in the development of the periodic table.